Okay, this video is 1.3, or at least the first part of it, starting with question 9. So all of these are about transformations of a graph. So if we look at this, our parent function is x cubed. So that looks like this. There's your parent function, standard little zigzag. What we want to do is describe what has happened to it by going through this transformation. So let's take a look. The first thing we have to do, anytime we look at a transformation, we have to make sure that we are in that standard form, the key being that we get x by itself. So we really want to say y equals -3, negative in there, and then instead of parentheses 2x, we need to pull that 2 out front so that there's a parentheses x by itself. But when we do that, we have to be careful because now we can't just say +4. We have to say, if we redistribute, we have 2 times x and then 2 times the other term, 2. And that gets us our +4. Then we close the parentheses, we add our cubed minus 1. So that's just the first step we always have to check for. Sometimes it's done for us, sometimes it's not. All right, now let's look at the order of operations of transformations says. Step 1 is always deal with it inside most parentheses, is what it says. What that means is right here in this little x plus 2, we have a shift to the left since it's plus. So I'm just going to list that left 2. That's one of those most people just have it memorized that a plus inside that parentheses actually means going to the left. So we've got the insidemost parentheses taken care of. Next thing on the order of operations, it says deal with all multiplications. And in that case, we actually do have 2 of them. We have the 2 out front of our x plus 2, and then we have a -3 out front of this x cubed. So the 2 on the inside, 2 is always, or the inside is always horizontal, compressing and stretching. So when we have a 2, we have, first of all, we're inside, so we have a horizontal. And then from there, we have to take into consideration when the number is a big number, like something bigger than 1, a 2, a 3, a 5, that is what we call a horizontal compression. And we always, again, use the descriptor as the reciprocal. So it's a compression by 1/2 because the number inside the equation is 2. So we've dealt with that multiplication. The other multiplication we have here is this 3 out front. And when there's a multiplication on the outside of the function, that is a vertical component. And this time, when it's a big number, bigger than 1, like a 2, a 3, a 4, those for verticals are stretches. Vertical stretch, and we just leave it as a 3. Now, the third order of operations says deal with all negations. So if there's a negative inside with the x plus 2 or something, we deal with that. But we don't. We have the negative out front. And when we have a negative out front, that is a reflection across. When it's on the outside, that's across the x-axis. Okay? So some people have that kind of memorized, if you will, by the fact that if there's a negative sign on the outside, we kind of work left to right, outside to inside. From left to right, we have x and then y. Alphabetically, x comes first. So if there's a negative out front, that comes first. X comes first. Our reflection is across that x-axis. There's no negative on the x, so we don't deal with any other reflections. The last step of the order of operations instead says we have a shift down by 1. All right, there's question 9. I think we can get 10 done and call it good. So let's do that. Let's look at number 10 here. Again, we're going to rewrite this so that it is written in the proper form. So 1/2 f. Again, f is just simply a placeholder. F could be representing the square root symbol, right? Maybe this is the square root of negative 3x plus 9. Or maybe it's 1/2 times negative 3x plus 9 squared. The f is just that placeholder for some parent function. That doesn't change the fact that we need to get it out by itself, negative the x, that is, by itself. Oh. Always be careful doing these factoring out, because even though it was a plus 9, we're going to factor out the 3. We also have to account for the fact that we're pulling out a negative. So when we do the negative 3 out front, we also have to account and say, oh, it's now x minus 3. Right? Because if we distribute, negative 3x becomes negative 3x. Negative 3 times negative 3 gives us plus 9. All right, so order of operations, deal with the innermost parentheses. Minus 3 is to the right by 3. Next up is all multiplications. We again have 2 multiplications here. I again usually deal with horizontal, just because I work from inside out too. That's a horizontal big number greater than 1, so we say that's a horizontal compression. And again, with horizontal, we use that reciprocal, so by 1/3. We also have a 1/2 out front, so we have a vertical. Because this one's less than 1, it's a fraction, vertical, this is also a compression. But we leave it alone and we just say by 1/2. Okay, so we've got multiplications taken care of, our inside parentheses. Next up would be the negations again. So now this time we have a negative, but it's on the inside. So this would be a reflection. But this time, because it's on the inside, that would be the second. So x comma y, reflect across y-axis. After dealing with negations, we deal with any shifting up and down, but this one does not have that. So we are done with question 10. It seemed to go a little bit quicker. But again, as a recap, the negative on the inside is going to reflect across the y-axis. And it has to do with the fact that when you're evaluating an x-y coordinate, you deal with the x on the inside first. And so what we're doing is we're saying, hey, instead of going to the right, let's say we're going to say 0.2, like x is 2. So instead of going over to the right 2, we have a negative sign here. And that negative sign means instead of going to the right 2, we go to the left 2. And what that looks like on a graph is that we've reflected across the y-axis. So I guess we have 2 more problems, but just to be a good time to recap that always make sure you have it in the general form where x is by itself. Make sure you're careful that you check to redistribute your coefficient, like the negative 3 here or the 2 here. Just make sure that you eventually get back to the starting equation. And the rest is up to you. So next video is up on questions 11, 12.